Okay, let's solve the PPP problem together. But before we move on, Jaewon asked why we are using the term rotation here, and what does it mean by left rotation? Here, as you can see here, this connection is maintained. However, we are rotating Z to the left direction and Y comes here. So it is like we are rotating a connected circle. And because we are moving Z to the left side like this, and Y follows here, and X also follows here. So it looks like rotating something on the left direction. So that is why we are using the term rotation. So does it answer your question? So because we are replacing Z with Y, and the connected X follows here, and this connection is maintained. So it looks like in the perspective of this line, Z, Y, X are rotating in a circular manner. Okay, that was why we are using the term rotation. And in fact, modifying this insert method is pretty simple. After we perform the insert operation, what we are going to do is just check whether we need to rebalance or not. And to do so, we're going to recompute the height. And after that, we're going to just return self.restructure. That's all we need to do. Okay, so this is what we just need to do. After these operations, we just recompute the height. And when we remove some items, we also need to recompute the height. So how are we going to do that? When we remove first, we're going to calculate recompute the height after this remove operation. And then if we need to restructure, then we're going to just restructure. Otherwise, we're going to just return self. That's all we need to do, okay? So this is just 2 lines of code we need to add. And in the case of remove method, what we are going to do is, at the end, we're going to just check whether we need to recompute the height or not. And then we're going to restructure if we need to. Okay, that's what we are, how we can modify this remove first and insert operations. Just at the end, we just recompute the height. And if we need restructuring, then we just restructure. That's all we need to do. Okay. So that was our AVL tree. And implementing dictionary does not change because this dictionary just uses the interface of binary search tree. So it doesn't care whether it is normal binary search tree or AVL tree. And this was the test case we used in the last lecture. We're going to run, and they just give you the same answer, same result, like this. However, this might be somewhat different. So we're going to add 100 items. This is somewhat awkward. Anyway, the result is going to be, there might be some errors in my implementation. So I'll just show you the result of executing this part. It's going to look like this. So even though we add 100 numbers in an increasing order, the tree finds its balance, it's on its own way, and the maximum height is going to be 6 rather than 100. So by using avial tree, we can achieve height balance.